In this lesson, we'll explore the Equal Scallop toolpath and how that might be a more effective toolpath for this type of geometry. The Equal Scallop toolpath creates a consistent scallop motion across the part, so not necessarily just in 2 dimensions, but in 3 dimensions. So it's relative to the step over distance. And it generates noise-free motion with the ability to smooth out some sharp corners, or convert that motion into a spiral approach while avoiding step over moves. So like we did before, let's take the last toolpath and copy it down. And then we'll change this to an Equal Scallop toolpath. So I'm going to move the arrow down to the bottom. And under the toolpath type, we'll choose Equal Scallop. And under the tool, I'll do this now because I typically forget, we will change this to Equal Scallop. Now under the cut parameters here, you notice that we get to choose a scallop height and a step over. So the scallop height will specify the spacing between cutting passes in terms of the height of the scallop that is left behind. So Mastercam calculates a step over based on this value, and of course also the tool that is selected. And the step over, this defines the spacing between cutting passes, but this is a 3D value measured along the surface profile. And it is linked to scallop height so that you can specify the spacing between the passes in terms of the step over distance or the scallop height. You'll also notice up here we have the option of expanding inside to out, or if you turn that off, it's outside to in. Let's click OK, recalculate, and we can explore this result. Okay, so the toolpath was calculated, and if we take a look at the results, we'll see we have what appears to be a constant scallop all along the part. And notice how it's jumping in and out of certain areas. This could be adjusted by the Optimize section. But in some of the areas in here, you can see how it's working from the outside in or the inside out, and the step over is very consistent. And even along the walls here, we're not really doing a lot of back and forth motion, as that would impact the surface finish differently than going up and down. Now there are some options that we can adjust in here, which would help some of the retract motion and so forth. So if we take a look in the parameters here, of course we have our linking parameters that you saw before, and you can adjust a lot of these entry and exit motions in most of these toolpaths to adjust how the leads appear. And that's why we have leads up here, how they appear and how they work with this toolpath. If we want to look at the cut parameters section, we can turn on Optimize just to see if that gives us a better result for how this toolpath gets created. So let's regenerate that and take a look. And that's the beauty of the toolpaths like this, is you can go in and make adjustments and investigate those adjustments. Now this is a much, much cleaner toolpath based on Optimize. And if we see here, we work out the island, so to speak, first, and then we work all the way out from the inside. In the next lesson, we'll explore the raster toolpath and how that might be a wise choice depending on the surface you're trying to machine.